my name is Michael and I'm the team leader for Team Reflection. I came up with the smart mirror idea as it was something that I've seen once and it looked like fun to do. And then I pitched it to the team and everyone picked it up and decided to do it. So my role for the team was doing the electronics and doing the Python code. So the Python code was majority of the LED strips. It needed a Python script to work.
Hello, I'm Ashley. I'm a member of Team Reflection. I was a software developer for the Android side of our project. I created lots of different parts for the Android project, including the GUI. I then worked on creating things such as the RSS feed, as well as speech recognition, API for the weather system, and all round working to ensure that the entire Android project created a good finished product for the entire system.
My name's Mahaveer and I'm the Android software developer at Team Reflection. My role was to create the face detection feature for the Android mirror. So I did that by using Google's API and integrated it into the application. I also helped debug with the Android project. So I helped fix many of the bugs of the application, and I implemented a few features such as scrolling view. So lets the news feed scroll down.
Okay, my name is Mo and I was the front-end web developer for the team. I was in charge of making the HTML or the web version of the smart mirror as a backup plan in case our initial idea of the Android-based system wouldn't work. The HTML smart mirror that I developed consisted of a combination of CSS and JavaScript.
My name is Oveys. I'm part of the reflection team. My job was the animation. What I did was a boot up screen and I done a screensaver for our mirror.
So this is our system block model diagram, and as we can see, the Android C2 is at the center. Through USB, we've got a wireless adapter connector, which is the Wi-Fi. We could have that, but as it's going to be a mirror, a smart mirror, we need it to have, Wi-Fi. For the GPIO, wiring pi, which is a library file that connects to the Android's GPIO pins. It is then and then the Python script is using its library files, and then the LED strip is being controlled by the Python script. On this side, we can see that the monitor is connected to the Android by HDMI, and then the monitor also has speakers, making it, if we're producing sound, that's where we would hear it.
Okay, so this is our original model that we designed, because initially we were going to have a frame which the monitor would fit into. Behind the frame would consist of our RGB strips, and in front of the frame we would have a two-way acrylic mirror, which is how we get the effect that we're after. And the whole system is powered by an Odroid C2 and a Wi-Fi adapter for wireless communications. Later on, as the project progressed, we took into this model, as you can see here. So the main HTML smart mirror system contains JavaScript and CSS. The HTML body has a RSS feed from the BBC News website and an RSS feed from the front page of Reddit, including a weather API and the time, which is controlled by the JavaScript. All of this is contained within a folder that's stored in the Azure Cloud Server system, which can be accessed through a URL in the web browser, and all of this is being powered by the Odroid.
So I was tasked with doing the lighting system for the smart mirror, and what I was tasked with is making a RGB controller for the RGB strip, and this is basically connected to the Oidroid, to its pin, and it uses MOSFETs for the switching when it receives power from, when it receives a signal from the Oidroid, it will switch and allow power through to each designated LED strip. This over here is the wiring diagram for it. As you can see, the 3 different MOSFETs for each color RGB, and it also shows that the LED strip, and it's got the power in, which is the 12 volts. It's got the drum connector that connects everything together, and it's got the Oidroid. So as we have the RGB controller connected to the pin headers of the Oidroid, we have to use the pin layout. The reason we have to use the pin layout is because it tells us the pins of the Oidroid that we're connecting it to. And it's also connected to wiring pipe. So we're using the wiring pipe GPI controller on the actual Oidroid native. So this is our Python script. We're using a wiring pipe to a library, and we're importing the time result because we're using delays. Firstly, we have to initialize the pins, blue, red and green, from our pin layout that we got 0, 2 and 3. We can set them on. We also set them to off when we start it up, so it didn't initially stop. So first we start with the delay, with them off again because it cycles through. So we have to turn off the previous LEDs off. So the first one we turn on green. We have the delay. We turn on red, and then we turn on blue. And this is when we start mixing the colors. As you can see from RGB, we can see 2 and 3. 2 and 3 is green and red. Green and red becomes yellow. And then so on, we have magenta and then cyan, and then the last one is white when they're all on. That's why we have to turn them off. Okay. I'm going to demonstrate the LED strips working now. And the code for it is sudo python and then the name of the file. So it turns it off. Green is the first one, red is the second one, blue is the third one, yellow is the fourth one, magenta is the fifth one, cyan is the sixth one, and white is the last one. And then it should cycle through. So we had intentionally decided to make the LED strips work with the website. So we would turn it on, have it cycle through, and then the moment the website would turn on for the smart mirror, the LED strips would be at the back flashing, as you can see my hand here. And then that's how we potentially had it. Either by when the Oidroid started on, or even when the website was turned on.
So for the web-based smart mirror, originally we were going to use the ambient operating system because it's a low resource Linux distribution, but unfortunately it doesn't support or have the ability to rotate the GUI, which meant we had to revert to another system. So for the smart mirror we had 2 systems. One was powered by Android, and the other one which I developed was HTML based. So the system that I designed consisted of Bootstrap, which handled all the design and UI elements to keep everything responsive, and we have 2 iframes that pull in weather data for us, which is right here, and it's for Gillingham. Then we have our code which contains all of the elements required for the clock, which I'll show soon. And then we have another 2 iframes, or classes rather, which have our RSS feeds. One is for the BBC and one is for the front page of Reddit. The style CSS page contains all of the positioning and font styling and background color that we needed in order to create the effect. And then followed by our JavaScript, which is what handles the clock function. So if we go into the web browser, the way that the system is able to host the Smart Mirror system on the web page is through the Microsoft Azure Cloud Platform. So we have a dedicated web server for the Smart Mirror. And if we go into here, so I've got it currently in debug mode. So when we have a screen that's in portrait view, this is how the system will look. So we have the weather that I mentioned earlier, which is an iframe, and it's taking live data from a web source. We have our digital clock, which shows the days, the seconds, and if it's AM or PM. And then right at the bottom we have our other 2 iframes, which are showing RSS feeds from the Reddit front page and the BBC News page.
When you no one's shit.
So as I mentioned earlier, the reason why we couldn't use the ambient operating system was because the operating system didn't support the ability to change the GUI to portrait mode. So what we're using here is Ubuntu Mate, which is similar to Ambient. It still uses Debian as its backend system, but has the ability to change the user interface into portrait mode. So when the system runs, it will load up the web page, which has the Smart Mirror set to the home page on boot up, and you may be able to see in the reflection this is how it will look for the user. So as I mentioned before, we have our mirror in the top left corner, we have the time on the top right, and then at the bottom 2 corners we have the Reddit RSS feed and the BBC News RSS feed, and that is our system.
Well, as you can see here, I made this design for my Magic Mirror in the introduction. So when we have our Magic Mirror on, then this design will come up. So we just said it would look very presentable, very nice. So when I done this in a special effect, but it took me like a couple of days to get it on it. What I did first was to write the name, the Magic Mirror. Then after I done the cutting and editing and other stuff which I had to do to get all this blue, as you can see, goes around it. So all this stuff, it took me like a day or 2 to do it. But I had to look at a couple of videos on YouTube to learn it, which was very hard and very difficult to do at the beginning. But then I got it done, which it looks very presentable, very nice. It'd be very good for an introduction when you want to do it. So like the whole Magic Mirror will come up and it will look very nice as well. As you can see, this is the second design I have done. It should have been a screensaver. So because we had like empty space for a black mirror, so I decided to do this animation, which will look very nice. The Android itself will come up, which will be very presentable as well. These 2 animations, both they work for Android and Android as well. So it can be used for any of them, anytime they want to use it.
Our Smart Mirror is powered by the Oveys C2, which is connected to, which has a wireless adapter, so we can connect to the internet. It has it's connected to a webcam, which will detect the user's face and voice, and the Oveys itself is powered by a power supply, which also powers the monitor, which will display the interface.
Okay, so our Odroid C2 is powered and controlled using Android Mobile OS. Using this OS, it meant that we could create an application for our smart mirror. As you can see here, we have an Android application running on the OS. This application features a range of different features. One of the things that we brought in was the Pocket Sphinx speech recognition library. This allowed us to have an offline speech recognition library using the microphone, and we've programmed in our own dictionary so that it has a set of designated words that it can recognise and is constantly looking out for, so that it can control all the other features in our application.
The face detection is powered by Google Vision, which is Google's API for detecting face detecting face. It can also detect emotions and objects as well. But just for this project, we're solely focusing on face detection.
So another one of the features that we brought in is the use of various different text fields on our smart mirror, such as the Open Weather API, which has been used. We're getting that from the internet through the Wi-Fi adapter, and that allows us to display up-to-date current weather data for the user for their nearest provided city. We also are able to bring in various RSS feeds. The ones that we've got in this test demo at the moment are BBC Technology and BBC News. Both of these text fields can be controlled using the speech recognition, which allows us to either hide these text fields or change them between the various different things. And these are all, like I said, these are all been read through the internet using the Wi-Fi adapter to load into our application.
So when the app is initialized, it shows just the black screen. Behind this is a camera that detects a face. So whenever someone stands close to the mirror, the application will move on to the actual user interface. So the technology behind the face detection is Google Vision API. I can demonstrate the face detection now.
Okay, so as we've mentioned in our block diagram, we're including several different things. We've got our weather data we're bringing in for our API and our RSS feed. One of the things we did mention earlier was the fact that we'd be using speech recognition, which we can use to control this screen. We can use that to make the RSS feed over on the left hide and reappear. We can also make it change between currently two different RSS feeds, which are BBC News and BBC Technology. So all of these things can be controlled by the speech recognition, as well as we can make the mirror shut down and go back to the original sort of off black screen that you saw a second ago. So we'll demonstrate the speech recognition now.
Mirror, eyes. Mirror, news. Mirror, shut down.
Okay, so the previous demonstration you've just seen has showed off how our speech recognition software works. As I'm sure you heard, there were two parts to each command. There was the first part word, which was the word mirror, which this functions similarly to Amazon Echo and other such devices. They're constantly listening, and when they hear the words, such as for that example, the word Alexa, it then listens and records all other following commands. So with our device, it listens out, hears the word mirror. It's then listening for words such as hide, shut down, news, and technology, which upon hearing these words followed by the initialization command, it will then perform the operations such as the ones you've just seen, and that's how our speech recognition software works.
Mirror, hide. Mirror, news. Mirror, shut down.
Not smart. It can't detect sadness. No, it can't detect no jump. Mirror, hide.
Maybe you should jump and say at the same time.
Mirror, hide. No, that doesn't work either. So for our smart mirror project, brilliant, great start, like that.
So the mirror starts at a black screen. So it's just going to show you nothing but the mirror. But when the user gets close to the mirror, it activates the actual application.
Okay, so as you can see on this screen, we've got the weather data at the bottom right, which, as we mentioned earlier, is brought into the
Thank you, everybody.
So what I will want to do is I forgot feature works. So what's this? On the oil. It switches the component inside the
Workers.
Okay, this is a demonstration of the LED strips working.
And I've done the screensaver for
after the word mirror. It then say
That realization.
Got really careful.
here's a wild employee on their phone.
As always, checking out ready.
No.
Focus.
What do you think about that side?
No, he's not looking at you.